Hello, I'm Roy Ruddle, and this video shows you the first step of the 6-step data quality method. I've been working in data quality for more than 10 years, and we developed the method with input from data scientists and analysts working in more than 15 industry domains. The method is freely available, and you can download it from this GitHub link. We have designed the 6-step method to let you investigate the quality of your data efficiently, rigorously, and reproducibly. The benefits include, firstly, enabling you to do more in less time because the method tells you what to do. Secondly, reducing cost because we have grouped data quality checks into a carefully thought out order. And thirdly, letting you get better results because by following our method, you will understand the limitations of your data, correct misheld assumptions, and be able to clean your data as you progress through the 6 steps. We have created 7 videos, an overview, as well as a different video for each step. This video shows you how to do step 1, which is to check whether anything is obviously wrong in a worked example. The dataset is open data about car park fines. The whole dataset spans 9 years. This example uses one of the data files, which is fines issued or paid in quarter 4 of 2018-19. There are 2 parts to step 1. First of all, to read the documentation, if there is any, and there is for this example. And secondly, to do some basic checks. And the 5 that I'm going to show you are checking the file format, looking at some summary statistics, inspecting and thinking about some example values, which leads us to look at missing column names and some empty columns. As I already said, the method is freely available. You can use any software to perform the 6-step data quality method. The examples in the videos use Python, the Viz data quality package, and Jupyter notebooks. So here is the web page for the dataset. The data contains information about fines issued for vehicles not having a valid parking ticket while they're in car parks. And there are 6 variables: date, time, location, fine issued, discount available, and total paid. And if we scroll down a bit, then we get some other useful information. We're told that issued is the date a PCN was issued. PCN stands for Parking Charge Notice, although that isn't actually defined anywhere in this documentation. There's information about the fines, about surcharges, if you don't pay within 56 days, about a discount. If you pay within 14 days, we're told there are 2 levels of fine, £70 and £50, with half of that discounted if you pay within those 14 days. We're told there's information about the balance, and we're told that it is possible for that balance to be negative, in which case somebody has overpaid. Now let's do the analysis for step 1. And for that, I'm using a Jupyter notebook. First thing I need to do in this notebook is to load the packages that I need. One of them is a well-known pandas package, and another one is a package called Viz Data Quality, which I've written. Now the data file is a CSV, comma-separated values. It's in text format, but we still need to know how that text file is encoded so that it's read in properly. And I can do that using a convenience function within Viz Data Quality, and that tells me that the file is in an ASCII format. Now that I know that, I can load the file into a data frame, and in doing so, I'm making sure that only blank cells are flagged as missing values. Next, I'm going to calculate some general statistics about the data file using a convenience function in Viz Data Quality. And this is telling me the size of the file, that it's got 7,108 rows, it's got 9 columns. Well, that's different to the 6 columns that are mentioned in the documentation, and also 7,108 blank values. The next thing I'm going to do is to print out some example values. And I always print out the first and the last row because it's surprising what you can learn from those. The first thing I see is this strange unnamed 8 variable. We're going to come back to that later. That's obviously not mentioned in the documentation. Two others that weren't mentioned in the documentation are PCN. Well, it wasn't mentioned directly. It stands for the identifier for each of the parking fines, and also contravention, which we can see from the text there is the type of the fine. The documentation mentioned discounts and surcharges, but these don't appear within the data file, so they're going to have to be derived from the date information. We can see that there are 2 dates, not one, so issued and the last pay date. We can see that the dates are in a day first format, day, month, and year. We need to know that if we're going to import the data file properly. However, given that the data file is for fines issued in January to March 2019, it's rather strange that the very first fine is for 10 years earlier in 2009. Going on to look at the last record here, we see that this has a last pay date of 31st of March 2019, that's fine, but nothing has been paid. So it's illogical that there should be a pay date, but nothing has been paid. And then on top of that, if the fine is 50 and 0 has been paid, how come the balance is 0? That just seems plain wrong. Now let's go back to that strange column. If I print out some statistics about it, I find that that column has 7,108 missing values and 0 present values. In other words, it's completely empty, and it accounts for all of the missing values in the dataset. Another way I could have found that kind of thing out is using one of the Viz Data Quality convenience functions, which checks for a series of issues and then provides a report about the ones that actually occur. So there's one column name missing, there's one empty column, and there's an extra column at the end of the data file. All of those are down to that unnamed 8 column. So having found these issues, the last thing to do in this step is to clean the data by reloading it. When we reload it, we leave out that strange column, and we also import the dates in the correct date format, and now we're ready to continue with the next steps of the method. So in summary, we have identified a number of discrepancies with the documentation. The checks we made allowed us to identify the correct format for reading in the dates, and we also found an empty column and now have removed it. We also identified 3 outstanding issues which we'll come back to in steps 4 and 5. One of those is that some PCNs were issued 10 years ago. The second is that there's a last pay date when the total paid was 0. And the third is that the fine, the total paid, and the balance don't add up. We found all those from checking one of the data files. I can assure you that if we checked all 9 years of the dataset, we would have found some other interesting data quality issues. So to remind you where we are now, going forward, we have these 8 variables. The PCN is an identifier for each parking fine. Issued is the date the fine was issued. Location is the car park name. Contravention is the type of penalty charge. The fine is the amount in pounds. The last pay date is the date a payment was made. The total paid is also in pounds, and the balance is the amount outstanding in pounds. Once again, if you'd like to download the method, you can do so freely from this GitHub link. And if you have any questions, do feel free to contact me. Thank you.